Hi, today we're going to be talking about atoms, and here to help me is Alejandro. Atoms are composed of three different subatomic particles. On the inside, we have protons and neutrons. On the outside, we have electrons. These electrons are located on orbitals. Orbitals can only have a certain amount of electrons per shell. On the first shell, we can only have 2, and every shell after that can have a max of 8 electrons. The amount of total electrons dictates which type of element it is. Alejandro here has 10 electrons, so he is the noble gas neon. But if we were to take away 1 electron, he would become fluorine. Now, fluorine is very different from neon in nature because of the amount of electrons in its outermost shell. This difference gives elements a characteristic known as electronegativity. Electronegativity is the tendency of atoms to attract electrons. Our fluorine here is the most electronegative element in our periodic table. This is because it is only missing 1 atom to fulfill its outermost shell. Electronegativity is important because since the elements want their outermost shell to be full, they tend to form bonds with each other. These bonds are known as hydrogen, covalent, and ionic bonds. But before we get into bonds, here's a quick message about quantums.
Yo, I heard you want some energy. Well, I got the thing for you. Quantums. Now, we're interested in the electrons because this is where we get our energy from. More specifically, when an electron is in a high quantum and it goes to a lower quantum, we'll capture the energy that is released here. Now, electrons at low quantums are called low energy electrons. And no one really likes those, aside from oxygen, but we don't need to know that right now. What we want is a high energy electron, especially a really high energy electron. Damn, Julene, you looking good, girl. The first type of bonds we'll talk about are ionic bonds. These bonds involve the complete giving away of electrons. These bonds are between metals and nonmetals. This is because metals will want to give away their electron, while fluorine, the most electronegative element, will want to accept it. Now, in an ionic bond, lithium here would give away its outer electron, and it would stay with its 2 with a complete shell. And fluorine would accept the electron, and it will have a complete shell of 8.
The second type of bonds we're going to be talking about is covalent bonds. Covalent bonds are between 2 nonmetals, and unlike ionic bonds, they share the electrons like this, hydrogen and oxygen here. They are weaker than ionic bonds.
Now, since covalent bonds means we're sharing electrons, 2 things can happen. Either they're shared equally, which will lead to nonpolar bonds, or they're shared unequally, which will lead to the polar bonds. In this case, the very highly electronegative oxygen will want to keep most of the electrons, which will lead to a slightly negative side and a slightly positive side. This will give it certain properties, like in water, where it gives it a high specific heat, and the properties of cohesion and adhesion. However, non-polar molecules can be helpful too, just as in the case when we talk about macromolecules, and especially lipids, which are very important in the plasma membrane of the cell.
Hydrogen bonds are the weakest bonds we're going to be talking about. Hydrogen bonds are formed by polar covalent bonds. Hydrogen bonds only like to have fun, which is a fun little acronym for fluorine, oxygen, and nitrogen. Thank you for bonding with us.